In a previous video, we learned about using EC2 Image Builder for creating custom AMIs. Today, we're going to switch gears to look at another powerful tool, Hashicorp Packer. So Packer is an open source tool for creating identical machine images for multiple platforms, all from a single configuration. While EC2 Image Builder is a managed AWS service, Packer is a standalone application that can work with various cloud providers and virtualization platforms. So to understand a little bit about Packer, let's walk through Packer's key primitives. First, we have templates. These are JSON or HCL files. HCL stands for Hashicorp Control Languages. These files define the entire build process all in one. They're kind of analogous to Image Builder's pipelines. Next, we have builders. These manage the infrastructure where machine images get built. For AMIs, this would be the Amazon EBS builder, as you'll see in just a bit. Next, we've got provisioners. These are the steps that install and configure software within a VM after it launches. These are kind of similar to Image Builder's components. Finally, we have post-processors. These take the result of a builder or another post-processor and they process it even further. For instance, you could use a post-processor to upload an AMI after it's built up to multiple regions, or just apply tags to it or encrypt it. So this all sounds a lot like Image Builder. How's it different from Image Builder? First, we have flexibility. So Packer works with multiple cloud providers and can even build local VM images. Image Builder, on the other hand, is AWS specific and is designed to work seamlessly with AWS services. Next is the way that build infrastructure is managed. Packer requires that you manage the build infrastructure. Image Builder, as a hosted service, manages most of that for you. Finally, there's just the learning curve. If you're already familiar with Packer and it suits your needs, it probably seems like a lot just to get up to speed with Image Builder. Totally fair. To help you get started with Packer, we've produced a Packer template for building a PCS-ready AMI. You can find it in the HPC Ready AMIs recipe alongside the Image Builder resources. Okay, so let's go ahead and examine our Packer template. I've opened it up in Visual Studio Code. This will show us all the steps and configurations for building a PCS-ready AMI. So our template is structured into three main sections. First is variables. This basically defines inputs that go into the build process, region, instance type, source AMI ID, description, etc. Second are the builders. So this is where we specify our specific builder. In this case, it's going to be the Amazon EBS builder. We also set the root volume size, the instance type, and so on. Keeping in mind, there can be more than one builder, but we're only going to do a single builder in this template. Finally, we have the provisioners. So in this case, we're using a sequence of shell-based provisioners. Remember, Packer supports other provisioners besides shell, Ansible, Chef, Puppet, etc. The reason we're using shell is that this lets us reuse the same scripts that power the Image Builder components. Now, there's other ways to implement this design, but we figured it would probably be easiest to explain it this way. All right, so here we have variables. There's a bunch of different variable names, everything from the name of the AMI that's being generated, the prefix HPC Ready AMI, the region, the source AMI. This is important to either pass or change if you want to build from something else. Instance type, the default username. This differs depending on which operating system you're building, architecture, vendor, etc. Down here we have the builders, Amazon EBS, as I mentioned earlier. Basically, this is telling EC2 how to launch an instance that Packer can talk to. So that's all that you're really looking at here. It's also telling the name of the AMI that's going to get built from this instance. The most interesting part here are the provisioners. So as I mentioned, we're using a bunch of different shell provisioners, and they're roughly broken up into kind of a set of stages. So the first stage, in the first stage, this provisioner, it's type shell, it's going to make a temporary directory, and it's going to download a bunch of scripts. Basically common, install, blah, 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 .sh, and then it's going to make them all executable. The URL for this is just the canonical HPC recipes representation of these particular files. They're all getting downloaded to the same script, which is a temporary directory on the destination on the destination VM. So we download everybody, we make them executable, and then we do our first actual action. So this provisioner updates the operating system. That takes a couple of minutes, basically runs yum update, etc. And then we reboot the instance. So this is implemented pretty simplistically. It's just a shutdown restart. Do it now. Key thing, especially when you're using Packer, if you're new to this, if you have a provisioner where there's an expectation that the connection between Packer and the remote instance is going to get disconnected, you have to tell the provisioner that. So we just literally tell it that by setting expect disconnect to true. Okay, so instance is rebooted. Next step. This is basically another shell provisioner. We're going to wait 2 minutes before we start executing these. And that's to give the instance time to reboot after it's disconnected. We're going to optimize the performance, install CloudWatch, SSM, EFA, Lustre, EFS utils, PCS agent and Slurm, and Spack. This should look a whole lot like what you just saw in the EC2 image builder example in the previous video. When this is all done, we're going to be a good citizen and clean up opt Packer scripts. That's because these don't really have any utility beyond the image build lifecycle. So this is it. It should be pretty obvious how this maps conceptually to the various stages in the image builder lifecycle that we looked at previously. So with that, let's go ahead and kick off an instance of Packer build. So let's go ahead and use the template to build an AMI. And we're going to use the Packer CLI for this, which I've already installed on my local system. We need a terminal, so let's pop up the terminal. Note that I have a copy of the template on my local hard drive. That's because I've checked out the HPC recipes repo, but really all you need is the template.json file. So the simplest build command is just going to be Packer build template JSON. That's all you actually need. If you do this, all the variables that are set by default in the template will be what get populated into the builders and the provisioners and the resulting AMI. But I think it's important that I show you how to pass variables, because that's really the way that you can use this generic template to build all the different supported operating systems on these supported architectures and supported instance types. So let's do something real simple. We'll do Packer build, and then the key to passing variables is this -var option. You can have multiples of these, basically one for each variable that you want to pass. And in this case, I'm just making the root volume 100 gigs instead of 64 gigs. There's a whole bunch of, obviously, a whole bunch of other things that we can pass. Packer doesn't care. You're just populating a dictionary that goes into the Packer build process, and that's used to populate the template instructions to build, to do all the build infrastructure stuff. So let's go ahead and kick this off. And what's going to happen here, now we're not going to follow this all the way to the end, but basically every single step in the Packer build process is now going to get output to your screen. And this is really handy for debugging because you can just track every single thing that's happening as it goes along. So here we go. We're already provisioning. We've launched an instance. It's running update OS. And et cetera, et cetera, et cetera. This will take just a couple of minutes. And we're actually not going to follow this. We're just going to kind of come back and check in with it after the instance build process has completed. Okay, so the AMI that we just built doesn't include any or very much HPC application software, just foundations. To add more, we can use the Spack installation that we did put there to run some install Spack commands. Now, you've got a lot of flexibility in how you do this. The way I would do it is we could just add a provisioner at the end of the template that runs some Spack commands. So let's just go ahead and mock up doing that. So here we are. Here are our provisioners in that original template. And I'm just going to add this to the end after we do the cleanup. There we are. So basically, because we can assume that Spack has been installed, we actually have access to Spack So we can do sudo opt-spack install. Then we can install 2 versions of OpenFOAM. OpenFOAM Community, we'll install version 10 of that, and OpenFOAM Supported, which is version 2112. And you can install multiple versions, et cetera, et cetera. That's kind of the beauty of Spack. So this is one approach. Another approach is that you could create another template where the input is your pre-built HPC ready AMI that has EFA, a Lustre, Spack, et cetera on it, and you just have a single provisioner that does the software installations. As you can imagine, that's going to be faster and kind of more iterative, because all the other steps don't have to get run every time you want to regenerate a new AMI. Either way, it's totally your choice. There's positive and negative. There's positives and negatives to each approach. It's totally up to you to decide. HPC Recipes and Packer gives you the tools and the flexibility to make that decision yourself. In this video, we learned how to use Hashicorp Packer to build AMIs for PCS, just like we did with EC2 Image Builder. So both Image Builder and Packer are absolutely great for automating AMI creation. Image Builder provides a managed AWS native experience. Packer offers a lot of flexibility and, critically, cross-platform capabilities. The choice between these two often comes down to what your specific needs are, the tool chain that you're most comfortable with, and the expertise of the people who are going to be maintaining things. So in a future video, we'll look at how to connect PCS to automated build pipelines so your compute nodes can always be running secured, up-to-date software environments. Until then, happy hacking.
If you enjoyed this tech short, please give us a like and consider subscribing to the channel. If there's a topic you want us to focus on, reach out to us at askhpc@amazon.com. We want to make it easier for scientists and engineers to solve the world's hardest problems. We think the cloud can help by giving them access to powerful tools of any shape and size whenever they need them. And that's where you come in. Let us know what you need. We'll see you next time.